And we're back for more. We're going to talk about building out the network, as you mentioned at the end of the last one, and
Yep.
we're going to talk about how we use Hyper-V to do that. It was funny when you built that first diagram that you were showing off in module, I believe, 2, with the VMs and the switches and the router in the middle and your connectivity, and talking about how that's useful for testing the cloud, testing clients, testing servers, having the guest server and the domain controller. I was looking at, you said Hyper-V switches sitting there. I was like, Hyper-V switches? How do you... My brain, because it's been a little while since I've worked with Hyper-V, really on a day-to-day basis. I mean, I haven't touched a Hyper-V in 6 months or so. I started thinking to myself, Hyper-V switches, like, are you building a VM that you're using as a switch somehow? For some reason, I had a little moment where I just forgot the entire network infrastructure of Hyper-V and the fact that you have to build switches to which you're going to connect your Hyper-V virtual machines for interconnectivity between them. So that's what we're going to talk about, is how to build those switches, what the different types of switches are, and how the virtual machines communicate once they're built.
Yeah, that's right. That is truly the centerpiece of this module. It's crucial that you understand how Hyper-V networking works. So let's look at our agenda here. Working with virtual switches, no surprise there, configuring the virtual router for use with those switches, and connecting to the internet. I do want to say that we could have very well have used the routing and remote access service built into Windows Server. You know that Windows Server has been able to be a router and VPN concentrator since Windows NT, since almost the beginning. I intentionally chose to use VIOS because to do it with RAS would have required another Windows-based VM, and I wanted the lab to be as real-world as possible. I wanted the router to behave more like an appliance. So that was my rationale for using VIOS. Let's get into understanding what virtual switches are. This Visio diagram attempts to clarify the 3 types of switches in Hyper-V and how they work. Let me break this apart piece by piece for you. There's actually 3 types of switch: external, internal, and private. Now, if you don't know what a switch is, let me briefly describe it. A switch is normally a piece of hardware, but in this case, these are virtual switches, or V-switches in Hyper-V. They're software-based, but it's a connectivity device in which each port gives a machine or a node on the network dedicated bandwidth. So if you have a gigabit switch, each port on that switch is going to provide full duplex bidirectional communication between a specific node and the switch at a given speed. And the switch has a layer of intelligence built in such that it knows who's on which port based on the network interface cards of each host, their MAC address or their OSI layer 2 hardware address. Okay? So that's what we're looking at here. Although switches can do routing, the switches in Hyper-V aren't that smart. They're what are called layer 2 switches, and we don't need to worry about that anyway. All right, back to the slide. What we have here, first of all, is the external switch option. And in Hyper-V, the external switch puts your VM on your own virtual. Let me repeat that. The external switch puts your VM on your physical local area network, or LAN. Let me use the highlighting pen here to show you this. We have an external switch right here, and this is going to show up in your Hyper-V server. I'm going to show you that in an upcoming demo. This is just a conceptual slide. And you see we have VM1 that has its own virtual network interface card. And if we associate the VM with an external switch, it actually gets bound to the physical network interface of your hardware host. And remember, on my computer, it's a Windows 10 Pro hardware host, and I do, in fact, have a physical network interface card. That means if I have, say, a dynamic host configuration protocol or DHCP server on my LAN here, that my VM can pick up an IP address from my DHCP server and access resources on my physical LAN just like any other host. Could even get out onto the internet if I had an internet connection on my LAN, you see? So that's what the external switch is used for, when you want the VM to appear on your physical network. Let me get rid of that ink. And next, let's look at the internal switch. The internal switch is what I would recommend for your CERT practice lab. The internal switch will link your VMs and the host together. Let me again bring out the pen and try to round up what's being connected here. In this case, it looks like both VM1 and VM2 have their vNICs bound to an internal switch, and the hardware host is actually bound to the internal switch. I'm trying to do an arrow and failing. I'm mousing with my right hand, but I'm actually a lefty, so that's why you're seeing some really ugly annotations here. But you'll actually see, and I'll show you what this looks like in just a moment, a software interface on the hardware host's network connection list that will be bound to the switch as well. So at the end of the day, to use a cliche, the VMs will be able to transparently communicate with each other and also the hardware host. You might think, well, why do I care about having my hardware machine be able to communicate with your VMs? Actually, there's lots of reasons. You may have files that you want to share with your VMs. That's one thing. You may want to do remote PowerShell or remote desktop from your machine into your VMs. There's lots of good use cases for the internal switch option. And it also gives you some isolation and security if you don't want your VMs to appear on your own home or work LAN, and if you want to shield your VMs from getting out onto the internet. Because remember, a virtual machine, even though to you it's just an asset that you're learning with, it's an honest-to-goodness computer, and it can be attacked and compromised from an internet-based bad actor just as easily as a production server or desktop system can. So I just want to make sure to explicitly state that these are real computers here, even if they exist in your sandbox. The third Hyper-V switch is called the private switch, and this is where you have the VMs on their own private network, and there's isolation even from the hardware host. Like I said, for our purposes, the most flexible option would be the internal switch. What about the router, this VIOS virtual appliance? You might have downloaded the ISO from the VIOS website, followed some instructions that you found online to install it, and then how do you configure it and how does it link up with your Hyper-V implementation? Well, consider this slide that has another Visio drawing that shows our lab network topology from a more network-oriented standpoint. I don't think I have to do annotations here. I think I've added them to the slide. Yes, I did, fortunately. In the center, we have our VIOS virtual router. And as I showed you in the previous module, I believe, there's two virtual network interfaces, ETH0 and ETH1, and I've bound separate IP addresses to those. Those IP addresses are going to be very important because they'll be used as what's called the default gateway for any hosts on either of our subnets. Hyper-V comes into the picture with the internal switch, and you'll notice that we'll create two Hyper-V internal switches, one for each network segment. So on the left side in the slide, the .10 internal switch will be linked to the VIOS ETH1 or ETH0 interface, as you can see. And on the right side of the slide, the 172.16.20/24 switch will be bound to ETH1 on the VIOS network. Outside, that is at the host level, I have a Windows Server 2016 domain controller called dc1.company.pre that has a static IP address of 172.16.10.10 and a default gateway of 172.16.10.1, which, as you see, is ETH0 on the VIOS router. Remember that the default gateway is used by a host if it can't reach a destination on its local subnetwork. Same thing going on the other subnet. We have MEM1 that's at .20.10 for its IP address, and it will use .20.1 for its default gateway. Same thing with my client machine that runs Windows 10. Now, my environment just didn't build itself that way. We had to build it ourselves. And hold on for that in just a minute. How do we get to the internet? Consider this final Visio drawing that I put together. The way, or the ways I should say, that you can link your practice lab to the internet are many. This is just one possible solution that you can do. In this example, we've added a third virtual network interface to the VIOS router, and I've given it the IP address of .30.1, and it is using in Hyper-V the external network type. Remember that external winds up getting bound through the host's physical NIC, that's what PNIC stands for, and if your physical host can get to the internet, so can that router. So the router will use its ETH2 interface as its own default gateway to get out onto the internet. Christopher, let's discuss this. Is your head spinning? What do you think about all this?
It's funny, as I'm listening to the description, I'm sitting here thinking to myself, I want a whiteboard. Now you have a diagram, so it's great. They can see what you're talking about, and it's all right there. But this is the kind of thing in a classroom I'd be drawing out one step at a time. We start here, we go here, we start here, we go here. Trace how packets flow through this whole network as you build it. So it's good you have the diagram and you can kind of follow along and watch how this is going. I've gotten to the point now when I plan out networks that are a little bit more complicated, not just a simple switch to maybe a router or just out to the internet. I will build something like this ahead of time just so I know what the steps are going to be, so I know what's going to connect where.
Yeah.
And it's not so much so that I can step through it, it's just that I don't want to lose something in the process. If you try to do it all from memory, you try it all and do it from a rough sketch or a rough idea or rough notes, you get it all built and you don't know why it's not working. And you've got to go back and trace through the whole thing to figure out what's wrong. With this built ahead of time, you're going to know exactly what your goal is, what you're hoping to have set up when you're done. It's easy to go in and verify and check. I'm a graphical guy, so I'll build something like this, then I'll cross things out as I get them done. So I'll know at the end what I actually got done and what I didn't.
Yeah. You know the old cliche, a picture is worth 1,000 words. I don't want to do blatant product placement here, but Microsoft Visio, in my opinion, should be in every certification candidate's toolbox. It runs in the cloud as part of Office 365 or as a downloadable application. And as you can see from these diagrams, as you work, you can document what you're doing, and that helps understanding because it can get kind of complex, as Christopher mentioned.
I agree with that. It's a very good idea. I've got a SharePoint background. We've talked about SharePoint. Visio is almost a requirement for SharePoint infrastructure building. Between sites, lists, libraries, subsites, I use SharePoint a lot, or Visio a lot, and I've used it for the same thing, diagramming just server infrastructure, networking infrastructure, so yeah.
Yeah, and not to get off the track too much with Visio, but one of the things I love about Visio is that it's not a static drawing either. You can do a flat network diagram, but you can actually populate your shapes with live data that you pull from anything from a CSV file to an Excel spreadsheet to even a live database. So the power that you can grasp in Visio with documentation is great. But anyway, back to our situation at hand. We're going to do a demo now in which we get into Hyper-V at greater depth. I want to show you the networking setup, how it works, and then we'll finish with creating a VM for those who haven't done so. I want to make sure you're familiar with that workflow. Here we are on our Windows 10 desktop again, and Hyper-V Manager is our graphical management tool for the Hyper-V feature. In Windows 10, you can find it just through searching your Start menu, or with Cortana, or just typing Hyper-V. You'll see it shows up in the best match right here. That's the graphical tool. And what I like to do for programs that I want to be persistent, we can right-click on the taskbar and select Pin.
It's funny, as you were looking for that, I'm thinking in my head, I would pin that.
Absolutely, yeah.
I do pin that, actually.
And I already have the lab pod set up, as you can see. Hyper-V on the left has a tree view that's especially useful in server environments. You can load up multiple servers and manage them all from one spot. But in client Hyper-V, we just have the local server, this machine called BDD Laptop. In the upper right corner, we have the virtual machines, which is a sortable list, as you can see. You can sort by state or by CPU usage or uptime. And then when you select a virtual machine, you see details. You see checkpoints, which represent point-in-time backups of the VM state. And then down at the bottom, you see metadata, including a live screen. It's probably small on how you're viewing the MVA presentation, but I can actually see the logon screen here in living color. And there's some other tabs here that are useful. I like the networking tab because that'll tell you what the IP addresses are, and IPv4 and IPv6 IP addresses, and what the status of the networking is on the VM. OK is, of course, what we want to see. All right, but before we get that, we have to consider the issue of networking. So to do that, we right-click the server and come down to Virtual Switch Manager. This opens up the Virtual Switch Manager dialog box, and it defaults to creating a new virtual network switch. And the choice there is pretty simple if you understand the difference between external, internal, and private. If I choose external, for instance, it opens up a new dialog where we can call this a unique name. I'll call it Test External Switch. We can give notes. And as I said, you're binding the external switch to one of your hardware host's physical adapters. And I can choose to bind to my Windows 10 laptop's wireless adapter or Ethernet hardwire adapter and go from there. I mean, there's a lot of options in Hyper-V that are simply beyond our scope, but Hyper-V is a super rich tool. I'm going to cancel that and come back to the switch manager. And if we were to do, say, an internal switch and click Create Virtual Switch, we can give it a name. I'll call this Test Internal Switch. And there's really nothing to configure. We can just leave the internal network option and click OK, and we'll have ourselves a new switch. I've gone through this already in building this lab, and you can see I have an external switch that I've simply called external that's bound to the actual hard Ethernet interface on my hardware computer. That is, I'm not sure if we even use this in this lab. We can use it for internet connectivity, but we rely on two internal switches that I've created. One, I've given the friendly name 172.16.10.0/24 to remind me of which subnet it's going to attach to. That's an internal switch. And another one with 172.16.20/24. Now, each one of these you'll see you can expand, and there's extensions. There's a lot of cool other stuff that we don't need to worry about. But just laying down the switches is pretty much just as easy as naming it, marking it as an internal switch, and making sure you remember which one to choose in the next step. And in that next step is where you bind a virtual machine to a particular switch. And this is where Visio can really come in handy. You may or may not remember that the domain controller VM, DC1, I wanted bound to the .10 switch. So what we can do is right-click that VM, presuming you've already created it, and I'm going to show you how to create one in just a minute in case you're concerned about that. Don't be. Right-click, go to Settings, and this is going to allow us to control the environment of the virtual machine, and what we're concerned with is the network adapter. And it's just as easy as opening the let me repeat that. And it's just as easy as opening the virtual switch dropdown and choosing the correct switch. I chose .10. Isn't that amazing? That's all there is to it. So that binds DC1 to the .10 switch. And on the other side of the router, we'll deal with the router in a second, we have MEM1 and CLE1. If I right-click and go to Settings there and come down to Network Adapter, we can verify that those are linked to the .20 switch. So we've aggregated them there. My Vios router is a virtual machine called router1.local domain. And actually, if you look down at the bottom here in the metadata, it shows that there's two virtual network adapters, and one is connected to .20 and the other is connected to .10. You may be thinking, Tim, you can have more than one virtual NIC on a VM? You absolutely can. Let me show you that. We'll right-click, go to Settings, and we can see, sure enough, exactly as I said, you have one network adapter on .10 and another one on .20. You want to check out, just as a sanity check, at least I want to check out, what the MAC address is, or the hardware address of each virtual network. That becomes important when we're configuring the router, because we'll see ETH0 and ETH1, but I would think to myself, wait a minute now, is this one with the MAC address that ends in 05 going to be ETH1 or ETH0? You see what I mean? So you can verify the virtual NICs generated MAC address by going under Advanced Features. To add additional network interfaces to a virtual machine, we can select Add Hardware and then choose Network Adapter. Now you'll notice that it's grayed out here. This is because the virtual machine's running. We'd have to shut down the virtual machine, come back in here to add additional virtual hardware. To finish this demo, let me show you how to create a VM if you haven't done so. And it kind of brings together all of the stuff that we've just been working with switches. We can right-click the server and go to New Virtual Machine to open the Virtual Machine Wizard. The good news here, at least I hope it's good news, is that all the skills that you're learning with Hyper-V here in Windows Client translate almost entirely to Hyper-V in Windows Server that's used in enterprises, well, businesses of all size, all around the world. So this is useful information for you and very practical for many reasons. Let's just call this New Server. This name is just a friendly name within Hyper-V. You'll name the virtual machine internally when you install the operating system. The default location for your virtual hard disk files is going to come under your Hyper-V Global Options. Remember when you right-click the server and choose Hyper-V Options? But you can override that and store the virtual disk in another location if you are concerned about disk space. I've been going with Generation 1, which is the older .vhd format, because I've been working with Azure a lot, and Azure virtual hard disks are Generation 1 and not Generation 2. Generation 2 virtual disks have the extension VHDX, and they have some additional features that Gen 1 doesn't, but for our purposes, it really doesn't matter. So for maximum flexibility with Azure, I would suggest Generation 1. The startup memory, this is important because depending upon how much physical RAM your host has, you don't want to give the VM too much RAM or too little. Dynamic memory is useful because you can provide an amount of startup memory, and then depending upon that cap, Hyper-V will adjust. I actually have not been using dynamic memory because it just slows down the performance of the VMs on my system. I would decide how much I can allocate. This laptop, I believe, it might have 32 gigs of RAM, but it may have only 16. But I've been going with 2 gigs or 2048 megabytes of memory for my virtual machines, and they've been fine because, after all, I'm not loading them down that heavily. Your mileage may vary on that, of course. We're asked to specify the VNIC, what switch it's connected to, external or one of the others. I'll choose external here. Next, we're asked what the name of the virtual hard disk is, where we're going to store it, and what size it is. 127 gigs is normally the standard. Notice that the disks are thin provisioned, which means they're not going to occupy the 127 gigs right off the top. The disks will only be the size of the amount of stuff that actually is contained in them. So next, this is how you're going to install an operating system. And you can just choose to do it later. You can use an honest-to-goodness DVD that's on your host server, or you could use an image file. Well, I'm going to click Browse because in my Downloads folder, I have a number of ISOs here. Why don't I select Windows Server 2016? And this is where your evaluation software comes in. Click OK, and then Finish. After a moment, Windows will provision the virtual machine. It shows up in the list, and then you'd go through the process of installing the operating system, which is part of the next module. So with that, let's return to our slide presentation and wrap this thing up. Christopher, any thoughts in closing on your end based on what we've been doing?
No, this one's pretty straightforward. There's not, I'd hate to say there's not a lot to it. There's a fair amount to it, but one of the things I've known about Hyper-V, one of the things I've enjoyed about Hyper-V the entire time is it's relatively simple to get started with and get into. So yeah, there's not much for me to add.
Yeah, and again, I want to say the simplicity of Hyper-V might lead you to not realize how powerful it is. I'm kind of stumbling over my words here, but businesses around the world use this for production workloads.
Well, it's no different than Azure. You think of Azure as this large, complicated, multifaceted product, which it is.
Yeah.
And then you think about VMs in Azure. How easy is
Right.
it to create a virtual machine in Azure?
Mm-hmm.
Takes a couple of seconds of my work and
Mhm.
2 minutes of time, and I'm running a Windows server in the cloud.
Mm-hmm.
That's not to belie the fact that Azure is an incredibly powerful tool that I'm now running a virtual machine in the cloud to do whatever I want with.
Yep.
Hyper-V is no different.
Mhm.
It's simple, but it's powerful.
Yep, exactly. What have we learned in this module? First, just to repeat, be careful with that external vSwitch type if you're anywhere near a production network. I've seen cases, I'm not going to say that I've done this necessarily in years past, but I've seen cases where you've got users at their cubicle or in their office wondering why their computer's not communicating. And then upon further investigation, we've realized that somebody brought up a DHCP server in their practice lab, but because they bound it to the external adapter, it's handing out invalid IP addresses to real people trying to do real work. So just, again, a caveat of that separation between production and lab. Remember also the point that your VMs have an attack surface just like any other host. For instance, if you have an external vSwitch connection to a VM and that VM is not firewalled, is not current with its operating system updates, it has defaults that are much better changed, don't be surprised if possibly, who knows what could happen, but just understand that that VM is every bit a TCP/IP host as a production machine. So with that, in the next module, we're going to populate our newly created virtual machines with relevant software. We've covered how to lay down the network foundations and to create our virtual machine shells, for lack of a better purpose and for lack of a better term, and to connect them to the appropriate switches. The next module will make sure that we've done our operating system deployment and make sure that our router is configured. That's a to-do item for next module for sure. We'll see you then. Thank you.